Now we will study force method to solve indeterminate beams. Indeterminate beams are those beams in which number of reactions are greater than number of unknowns are greater than number of reactions. So we consider an example. For example, on this side is fixed support and on this side is a roller support. First, an load of 50 kilonewton is acting at 6 meter distance from left side and 6 meter distance from right side. So now we will solve this beam. So first method to solve the indeterminate beams using force method is that we will study degree of indeterminacy. Degree of indeterminacy is equal to R minus 3n. Here R are total number of reactions. Here at fixed support there will be 3 reactions and at roller support there will be 1 reaction. So total reactions will be 4 and minus 3, and n is number of parts of beam. Here number of parts of beams are only 1 because no internal pin or hinge is present. If one internal hinge will present in that beam, for example at this place, then number of parts will become 2, but in this case number of parts are only 1. So degree of indeterminacy in this question is equal to 4 minus 3 is equal to 1. So the next step will be, after finding degree of indeterminacy, we will solve structure into primary and redundant structure. So primary and redundant structure. So primary structure for this beam will consist of this part and this part, 50 kilonewton, 6 meter and 6 meter. We have assumed that we are taking redundant force on the ruler. So on this one is primary structure, and in primary structure we will remove the redundant force, and now this one is redundant structure. In redundant structure we will remove all loads. We have removed this load in this structure and we will apply one force of one magnitude at the place of redundant. If ultimately we will sum up these structures, the answer of these structures will be same. For example, these structures and these structures are joined. This will result in the form of this one structure, which is the resultant structure. So we will solve just these two structures and we will be able to find out the reactions for the first given indeterminate structure. So first of all we will solve primary structure. For that we will write compatibility equation. Compatibility equations, we will write compatibility equation. Compatibility equations are written on redundant. For example, in this case we have this one is point A, for suppose this one is point B and this one is point C, and see this one is point A, this one is point B and this one is point C. So we will solve this. So compatibility equation will be written at point where redundant is taken. In this structure redundant is here, and in this structure redundant is here. So at the primary structure its deflection will be del C, and at redundant structure its deflection will be del cc. What is this force is showing? This del c is showing that deflection at point c with no redundant force, and this is showing that deflection at point c due to force at point C. So at the second ordinate force is acting, and at the first ordinate deflection is acting. So at second ordinate force is acting. So at any point the total deflections must be zero. We say that del C plus del CC is equal to 0 for the structure to be stable. So this one will be del C, and this del CC can be written as how? Force CY. The force acting at C is equal to, this one is CY force, which is assumed 1 in the redundant structure, multiplied by FCC is equal to 0. This compatibility equation is final. This FCC is flexibility coefficient. Force method is also known as flexibility method, and we will find out now the values of del C and value of FC. Then after putting these values in this, we will find out the value of CY, which we have taken redundant. So let us solve that. For that we will solve the primary structure. So we will say that solving primary structure. So this one is our primary structure we will form. So our primary structure is this one, and 50 kilonewton load is acting, and 6 meter and 6 meter. So first of all, what will we do? We will calculate value of reactions. Here will be reaction AY, here will be reaction AX, and here will be a moment M. We can take any direction of the moment. Ultimately, it will be corrected at the final answer. So we have consumed this direction. So we find these unknowns. This one is primary structure, and this is determinate structure. This must be a determinate structure. So equilibrium equation, Ax is equal to 0. No other x direction force is acting. So then by Ay, and the y direction force minus 50. Ay minus 50 is equal to 0, implies Ay will be equal to 50. And we will take moment at this point. So moment at this point is equal to moment of this force, and this force at this point will be 0. So only this force will produce moment. This force is producing moment clockwise. We will write positive as clockwise direction into 50, and this one is acting at 6 meter distance. So m is equal to 0. So value of moment will become 50 into 60 in minus 300. So we have calculated these values of reaction. So we will write these values of reaction is equal to Ay is equal to 50, and our Ax is equal to 0, and our moment is equal to minus 300. So the next step is we will write the equation of moments at different section of the beam. So and we can make only two sections in this beam. So first section will be this one for the beam from this to this, and this one distance will be our value of x. Okay, so we will write value of moment at cutted section. We have cut this section which is not visible clearly, so we will write the moment at this moment equation will be equal to, what is this value? Ax force is producing no moment, and Ay force, which is 50, is producing clockwise moment above this point and is equal to 50x. And this minus 300 moment will become there. This one is value of m, and in the interval 0 to 6, and for interval 0 to 6, and for interval 6 to 12 we will assume this, and the value of x will be this value. So at this distance only this force is producing moment about this point, so this will again 50x, and this will be minus 300 this moment at this point, same, and this force will also produce, this force will produce anti-clockwise movement, so we will consider minus 50, and this force is acting at a distance, and this total distance is x, and the is this one distance is x minus 6. This one distance is x minus 6, because this one is total x and this one is 6, so this one will become x minus 6. So 50 Newton force is acting at x minus 6 distance, so we will write here 50 into x minus 6. So this one moment is producing at this one section, so the value interval will be equal to 6 to 12. We have solved this one primary structure, and now we will solve the redundant structure, the other structure. This one is redundant structure, and now we will solve it as the same way. And the redundant structure is this one, this one, this one, this one, and no force will act in redundant structure, and here a value of only one will act. We are actually using principle of virtual work, and in this principle we can apply unit load at the place of redundant force and unit moment at the place of redundant moment. But in this example we are only considering force as a redundant, so unit load is considered as redundant. First of all we will find out reactions of this, so this will be ay and this will be ax, and this will be value of m. Okay, and the next step will be this one be 6 meter and this one be 6 meter, so this one is 1 kilonewton force, and the ay will also be 1 kilonewton. Okay, and the force, these two forces are producing couple. This one is 1 and this one will be minus 1. This is upward direction and this is downward direction. So the next step will be moment producing, ax will be 0 and these will are producing anti-clockwise moment in this direction, and in this direction negative. So this force will produce positive moment, and this direction will be 1 multiplied by 12, so this m will be equal to 12. By equilibrification you will also get this value. Structure should be in equilibrium, this in 12 moment clockwise, and this one is 1 and this one is minus 1, so this one is producing couple of 12 anti-clockwise, so our structure is stable. So now we will calculate value of m. This one is denoted by small m moment, and we will cut a section here and this value will be equal to, this one is x, and this force is producing moment of, this one is -1, this one will produce moment of -x, and this one will produce +12. Okay, this one are 2, other is nothing. This one is value of in 0 to 6 interval, and value of m into 6 to 10 interval. We will take x this value, and so we will solve it. In this case this will also minus x, and this will also 12. So 6 to 12, this one will value of moment in the 6 to 12 interval. Now we have calculated value of moments for primary structure and value of moments for secondary structure, and now we will calculate the values of unknowns, which are these ones are the unknowns del C and FCC, and I will now show the formula of these two. I will show the formula of these two and I will solve. So the formula of del C is equal to, what is this one? This formula is equal to del C, and the formula of FCC I will write here. The formula of del CC is equal to 0 to your limits. For example, our limits are 0 to 12, length of beam, and m. This one is for primary structure, and this one is for redundant structure, dx. So in this case it will be equal to, we have two intervals 0 to 6 and plus 6 to 12 dx. Okay, and in the FCC this one is equal to 0 to 12. In this case we take m values only just redundant moments multiply. In this way, one is primary structure moment and one is redundant structure moments. So now I will calculate these. This will equal to dx now. So as in this case both values are same, so this will become m square, and now I will show you these values. The value of m are 50x minus 300 for 0 to 6, and 50x minus 300 minus 50x minus 6. So the values in this will be equal to 50x minus 300. This one is value of greater m multiplied by value of smaller m. What is the value of smaller m? Value of smaller m is this one, minus x plus 12 from 0 to 6. This one will equal to minus x plus 12 will be equal to 0 to 6, and in this case value is 50x minus 300 and minus, now we will say what is this one. This one is minus 50x minus 6. So this one will be equal to minus 50, and this one is x minus 6, and multiplied by this one, the value of m minus x plus 12. Now we will solve these twos and sum these two, so we will calculate the value of del C, and in this case we will calculate minus x plus 12 and whole square. So I will calculate these values on calculator and I will show you these results. So we have to little wait to measure these values on calculator. So I will calculate first. So this one is integral is equal to, so minus x plus 12 whole square, and now lower limit is 0 and upper limit is 12. Okay, and this one will be, so values of this is equal to 5, 7, 6. So in these formulas below, ei is also involved, so our answer will be in this form. So in above formula also ei will be involved, and we will calculate these values, and finally we will write ei. So I am first calculating integration of minus, I am calculating this one first, minus 50x minus 300, sorry, this one is just 50x minus 300 multiplied by minus x, sorry, minus x plus 12, and okay, and this will be 0 to 6. So this value comes out to be minus 9000. So this is equal to minus 9000 plus, so next value is 50x minus 300 and minus, this one is equal to minus 50, and here x minus 6, and okay, and the next value is minus x plus 12, same. So in this case, but limits will be 6 to 12. So this value will be equal to, this value is equal to 0. So our values minus our del c will be equal to minus 9000 over ei. So in the equations compatibility, del c plus f c c c y is equal to 0, we have computed, and minus this one is equal to minus 9000 plus FCC, we have calculated, this comes out to be 567 over EY into CY is equal to 0. EY will be cancelled out when we will take common and multiply on the other side. So CY 576 is equal to 9000, and CY is equal to 9000 divided by 576. So answer comes out to be 15.625. So we have calculated this value, and the next step is we have converted actually this indeterminate structure into determinate structure. Here at the place of ruler we have force of 15.625 kilonewton, and at this force will be equal to 50 kilonewton. So what we have done, we have converted this indeterminate structure into a determinate structure. So by equilibrium equation we can solve these structures, and we can find out, so we can solve this structure by equilibrium equation. And next step, we can make shear force diagram of this beam. And third step is we can make bending moment diagram of this beam. In next stage, what we can do, we can calculate maximum bending moment from the bending moment diagram, and from maximum bending moment we can design steel in tension and steel in compression, where should be steel in tension or steel in compression. So this one was the overall objective to solve this indeterminate beam and to calculate maximum moment. So in this way our question has ended. At any type of question you can comment. So if you like our videos, so comment our videos and like our video and share our video more and more and subscribe our YouTube channel. Thanks for watching. If you don't like, then sorry.